let's just get cracking. So for the rest of today, just to be clear, we're going to talk a little bit about software engineering broadly. Then we're going to talk about Git. And then on tomorrow, we're going to be talking about some Python and testing, which is kind of the introduction to coding. And then we talk about iteration one, and we go through the specification a little bit. Now, I just want to flag again for the 5th time that this is not like one of those simple dimple courses where you just turn up and you get some code to write. We have to establish you in groups. We have to get you set up. Like there's a lot to take in the first week, right? So please, for anyone who's feeling a little overwhelmed or stressed and like you don't have a grip on it, just give yourself the week, because I guarantee you will do a couple of lectures. You go to your tute, you'll go to your lab. Your tutor will help you find your group members. Your tutor will help you guys figure out how you're going to communicate. You can talk about GitLab. This week is very much an orientation week. So if you still have lingering questions, that's what your tutors and lab assists are for. So we're here to help, and we're looking forward to making this week work for you. Now, software development lifecycle. Why do we need to talk about this so early on in the course? Well, this is an introduction to ideas that we're going to keep coming back to over and over again in this... Oop, link to the wrong thing. Sorry. Yeah. That we're going to keep coming back to. SDLC. The hell is that? I don't know what the hell it is. Do you know what the hell it is? Before we get into the life cycle, let's actually talk about software engineering. So, who here does computer science? Right? Who here does software engineering? Some people do. 2 different things. Yeah, me. Computer engineering too, come on. All right. Computer science and software engineering. Now, at UNSW, they're pretty much the same. Right, software engineering is basically the thesis is compulsory, and you have to do 60 days of industrial training, and you have a couple of extra courses, but largely they're the same. The industry sees them as the same. I have very, very, very rarely, if at all, ever seen industry go, "Oh, you're a computer scientist, not a software engineer. We're not hiring you." So the difference at UNSW itself is not really anything meaningful. That being said, conceptually, software engineering is this idea that software is more than just programming. We actually have to think about how systems are built, how they're managed, and how do we make sure that they do what they were meant to do, right? So it's kind of like the opposite of, like on one end you kind of have like formal practices, and on the other end you kind of have hacking in terms of just like bashing out code. And as we talk about software engineering, we're always going to be trying to pull you towards that more formal side and think, okay, how do we actually write code in a way that isn't just like spitting thoughts out on a page and hoping it works? I gave this contrast already. COMP1531, learning programming by writing code to solve problems. 1531, we're using programming in the context of the software development lifecycle. So, how would we define software engineering? There's a big IEEE. IEEE is like an international body that do some standards and stuff that says software engineering is the application of a systematic discipline, quantifiable, blah, blah, blah. Very interesting, very accurate, not very exciting or understandable though. But the way I would just describe it to you is that we're going to build thought out, testable and scalable software that meets its requirements. It does what it's meant to do, and we can make sure that that we can automatically actually test that it does what it's meant to do. Because you have to ask yourself the question, it's like, how does a company like Google or Atlassian or Facebook or Dropbox or Netflix or Amazon, how does their software just work? Right? How do they update their software all the time and it not break, right? You're getting new versions of Google every single day. Canva, Atlassian, they build their code daily. They ship it out daily. How do they do this without it breaking? Right? It breaks sometimes, sure, but like, how does it just function? You know what it's like. It's it's hard to... I've done projects before. I've written tiny pieces of code, and I can't even get like a linked list to work sometimes. So how do people get these giant international, you know, massive projects to just function? Now, why does this matter? Why does software engineering matter? So now you might think, oh, well, software engineering removes bugs. Okay, sure, but who cares? Like, why are bugs bad? Right? That's the question I want to kind of drill into you. Why are bugs bad? Why are problems bad? And you have to think about it from the perspective of a business. Why would a business want to invest in good software engineering principles? Why would they want to invest in people like you who are going to become good software engineers with a good understanding of these principles? And the fundamental reason is every time something breaks, it tends to cost more money, you tend to lose customers, things tend to go wrong. Yeah, you have security breaches. Like Amin says, you might not make money. Shayak, I'm not sure how to pronounce your name, sorry. Catherine says they have test environments for it to break it first. Yeah, exactly. So, you know, a company might set up a test environment to run their code. Why do they do that? It costs money, it costs time, but they do that because they think it's going to save them money and time in the long run by catching problems before it hits customers, before it hits the users. Because that's really what software engineering is about. It's something that any kind of entity cares about, because when you do it right, less things go wrong. And when less things go wrong, whatever you're doing tends to function better. So that's the motivation, right? Like bugs, sure, it reduces bugs, but who cares, right? You care because bugs cost money. There's a link here, bad things can happen. There's a funny article you can look at where they talk about things that go wrong because of like software mistakes. There's been rockets that explode, things been hacked left, right, and center. That's a funny cartoon, but we don't need to look at that too much. Okay, just before we jump into the actual life cycle itself, Luke has asked a question. I submitted a group preference for someone in my tute, but I just saw they're not in the same group. Okay, so there's probably a handful of people here who are in this situation where you've made preferences and you're not in a group with someone. There's three things that can happen. There's three reasons this might happen. One is because you and the other person are not in the same tute. The second reason is because I made a mistake. It took me like 4 hours yesterday to try and put all the groups together, and I'm sure I made a mistake somewhere. The third reason is because your tutor needs to structure the class in a certain way. The third one is not going to have been a reason yet because it's just the start of the first week. But if the other two reasons, just talk to your tutor basically. Like, if you are in the same class as the people you want to be in a group with, then the person to talk to is your tutor. Send them an email and just turn up on your tutorial day, and they will do their best to put you in the same group. Okay, and if you can't get in the same group as people, that's totally okay, because I think about 2/3 of the course did not preference or something like that. It's totally normal. It happens every term. People get in their head this idea that if I'm not with people I know, then I'm suddenly going to find myself crying on the street, smothering chocolate in my face, hoping for better days. But it's not like that. Most of you are nice people, right? I don't know why everyone thinks that like this cohort's full of like evil little useless munchkins, except your friends. So yeah, that got a bit weird. Back to the SDLC. So there's a lot of different diagrams on the internet that'll describe this process. This is the one that I like. There are 6 steps to this, and it starts at yellow and it moves around to orange. And the first step is called requirements analysis. That is the process by which you figure out what the hell you're doing. Like, I used to play this game with like I think like back when I used to be in charge of SunSwift. There's like a solar car team at UNSW. I used to sit the like mechanical engineers down, and I play this horrible game with them because I'm a bad person. They'd be mainly first years, and I'd say, okay, well, I want you all to build me a table. Okay, And then they all kind of nod, and then you know, and I say, do it in groups of 3. I want you to build me a table. And they start, you know, drawing things up and coming up with ideas and all of this. And you just kind of stop them after a couple minutes, and you're like, what in God's name are you doing? It's like, you have no idea what you're actually trying to do, right? Your action without purpose. And it's kind of funny because you do that all the time without realizing, as someone says, we need to, you know, I need to do this, I need to do that. But it's like, why? Right? So requirements analysis is this big question of why. And I'm going through this part now, but I'm just keeping the diagram up here so you can think about it. Like, why are you doing something? Right? When UNSW develops a new tool like MS Teams, they don't just say, oh, I'd really like to buy MS Teams or use it. They sit down and they say, what do we need? We need staff to be able to communicate. We need video calls to be able to happen. We need students to be able to communicate with staff. We need groups to be able to be made. We need files to be able to be shared. Before anything even happens, before any solutions start going forward, you focus on understanding the problem you're trying to solve. Okay, and requirements analysis is a big part of the course. It's one of the biggest chunks that we talk about. And I will probably, we'll talk about it more. I'm just wondering how much to talk about it now. But it's pretty much figuring out what you're doing, right? You know, I use another SunSwift example because it's just easy. When in 2015 we attempted to make our car road legal in Australia, and obviously when you do something like that, you have to build a lot. Like, you have to, you know, change things and build things and design things. But before any of that, you actually have to understand what you're doing. And in Australia, when you build a car or you import a car, you actually have to follow these rules. And they're dictated here on, like, the government, where I don't even remember where they are anymore. But yeah, I wouldn't even know how to find them. But there's a whole bunch of lists that I'm not going to be able to find, and I probably shouldn't ever try and do things on the fly like this. What was it? Australia ADR 3. Maybe there'll be something useful here. 3rd edition Australia. Here you go. So, like, in Australia, there's this legislation that dictates how the hell seats and seat anchorages should work. And this is a list of requirements. This is not an engineering document. It doesn't tell you how to build it. It tells you the rules in which you have to figure out what you're going to build. It tells you how things need to look. It tells you how things need to be. It's a funny looking car. And these are requirements. And in software, we actually don't talk about requirements enough sometimes because it's so easy to build things in software. You just open a text editor and you start typing code and you're done. But in reality, you know, you really need to actually think about what you're doing. Catherine says, can you distinguish between Agile and SDLC for me? We're going to talk more about Agile next week, but basically the software development lifecycle is like how to manage projects, you know, irrespective of whether it's 1 person, 10 people, 100 people. So it's a bit more of the inhuman part of it. And Agile, which we'll talk about next week, is how do you function as a team? So Agile is a framework for how teams can actually work together. You know, so, you know, how do you meet? How do you talk? How do you catch up? How do you sync up? That's more Agile stuff. So requirements analysis is a big part of this course. The second part of this course is design. So design is, I'd love to teach more design in this course, but we don't really have the time to. Design is what distinguishes crappy built software from well-built software. So if you think back to that software development lifecycle, requirements analysis is figuring out what problem you're trying to solve. Design is figuring out the elegant ways at a high level that you might want to solve it, and development here is actually coding the darn thing. Now, when you think of design, it's very hard, I think, as a first year, at least it would have been for me, to understand what we mean by design. So a way I might describe it to you is, you know how you might get a hard question in an assignment or an exam or a lab, and it says like, make a linked list. Write a function that will traverse a linked list and remove a certain element. If you just start like immediately writing the code for that, that's like void remove link, link start int index or something, something like this. If you just start kind of writing this out, the problem is you're not going to have thought about what you're doing. It's just going to kind of be what we sometimes call spaghetti code. You can Google spaghetti code. There's an article on it. I don't know why is that yellow? Oh, okay, that was weird. But it's basically spaghetti code. How do they describe it? Unstructured and difficult to maintain source code. So you've probably seen this before, right? You ever written an assignment? You start off, you write a bit of code, this is fine. You write a bit more code, you write a bit more code, and suddenly you have a lot of code, and you feel like every time you touch something, it breaks. Maybe you've got like 3 or 4 nested for loops. Maybe you've like got variables that are just higgledy-piggledy everywhere, and you're really scared to touch it. The second you're scared to touch your code, it may work, but it's poorly designed, right? So design, a very basic example of design is writing pseudocode, right? I have like a function called like function remove link. And then I'll say, you know what, if list is empty, do nothing. If list only has one element, return empty list. You know what I mean? Like you might write out your code like this. Thanks, Yuval. And when you write out your code like this is actually you engaging with the process of design, because you're thinking, you know what problems you have to solve, but you don't want to go and do it yet because you want to think about how to do it in a way that doesn't make you produce crap. Because the more crap you produce, the less it's usable. And in a lot of ways, funnily enough, when I think you start programming at uni, or at least young programmers, they think about their ability to code as being somewhat profound. Like it's like a badge of honor. Like I can write really tricky C, or I can write a lot of code, or I can write code fast. And therefore I am great. But here's the funny thing, and I always get worried when I say this that it sounds kind of wrong, but there's a lot of the developing world out there, Philippines, a lot of Southeast Asia, parts of the Middle East as well, and you can get people to program for you very, very cheap. Right now, if most of you go and get grad level jobs, for instance, in the software industry, just like a grad level at some tech company, you're looking at like an hourly rate that they'll pay you of about $50, right? You can hire programmers from parts of Southeast Asia for like $5 an hour, and I guarantee you that they will program probably as good as you will. Like they'll get code written as fast as you, and it'll probably work enough. Maybe not as much as you, because in theory you should be better educated, having spent all these years studying, but they'll get a pretty good job done. But what they will suck at in general, comparatively to you, is the ability to understand requirements, understand what problems you're solving, and to design good systems. The actual coding part of your career is really not something that you should stand on above all else, right? And that's why these things are interesting to talk about. That's why I wish we talk about more design in this course. We don't have the time. But being able to make sure you're solving the right problem and make sure you're architecting a good solution are two really, really, really critical things. Because that is kind of where, like, and as someone who like hires software engineers, that's one of the main reasons that we hire people locally, for instance, in many cases. Don't get me wrong, there's plenty of good software engineers out there internationally. That's not the point of it. But if I want to hire someone for $5 an hour, they'll get code written quickly, but they will often misunderstand the problem, or they will kind of write a lot of spaghetti code, like the hard to maintain code, because they're just trying to get stuff out quickly. And that's on the cheaper end. So that's what you should be thinking about. You should be thinking about How do I get good at being more than just a coder? After you write the code, which is pretty straightforward, you actually have to test it. Testing is a big part of this course. And we're just basically going to help you write code and then test code straight after. We do a lot of testing. We do a little bit of testing tomorrow. And then I think we do maybe a tiny bit more next week, but it's mainly testing tomorrow. We try to get a lot done in week 1 so that you can start the iterations. You're all familiar with testing because you did it in 1511, I believe. I believe you guys still write asserts in 1511, right? Hope so. And then the last 2 parts of the software development lifecycle, which aren't actually a huge part of this course, are deployment and maintenance. Deployment is where you actually take code and make it available for use. This is something that I don't think is taught enough at universities. I'm trying to teach more of it because it's kind of relevant in a lot of places these days. But it's all well and good to write code, even work as a team, put it up on GitLab, test your code. But like, there's nothing that you can do with that, right? Like, okay, sure, you have your code, but how do people actually use it? I'm sure you made a game or something in, one of your programming courses, or you've done some kind of assignment, which was fun. It's like, sure, that was fun, but like, how do other people use it? If you write a command line tool, how do you put that up so that anyone on the internet can use it, for instance? So deployment is this process of making software available for use by real people and real users. And then maintenance is the last one. We barely talk about this. We mainly talk about it in concept. We don't get you to practice anything. Maintenance is like, okay, you discovered the problem, you designed a solution, you wrote the solution, you tested the solution, you made it available for use. What now? Well, make sure it works. Make sure it's stable. Figure out what people don't like about it. Talk to your customers and start again. And that's where the lifecycle part comes in. After you deploy it, you maintain it, and then you start to figure out, what do we do next? What other problems do we need to solve here? So a few people have said to me, so Jonathan, Charles, Shayak, Miguel, Girichand, I'm sorry about name pronunciations. You said that testing is not part of 1511. We'll take a break soon, by the way, don't worry. Testing's not part of 1511. Okay, there you go. Didn't know that. That's fine. We talk about it a lot here. So I understand that some people that have done 2521 will be familiar with asserts. Oh, right. Sorry. Oh, that's good. My bad. Okay, that's good. Yeah, no, asserts are just one way of testing. Sorry, I shouldn't have jumped to the conclusion there. If you forgot everything in 1511, I don't think that should be a problem. Because the main things that we assume your knowledge for in 1531 are that, like, you know what an if statement is, you know what a variable is, you know what a loop is, you know how to use the terminal. We don't like test, oh, do you know what what's the struct, or like how does a linked list work, or none of that. Cool. Okay, that makes sense. Thanks for the update about 1511. That's fine. I mean, everyone gets testing. You do stuff to check if your code works. So then the last piece is DevOps, which is just a little tack on the end here. This isn't super critical, but historically in teams there have been people who like work on deployment, which is like operations and maintenance, like 5 and 6. And then separate people that work on like development, and separate people sometimes that work on testing. So like, I think when I was at Microsoft, like interning and not as a grad, a long time ago, I think they used to have like test engineers and dev engineers is what they'd say. So you'd be hired as like an engineer to test. Some other people be hired as an engineer to develop. And then at other companies, they'd hire extra engineers called like operations support, deployment, infrastructure, whatever. And these people will kind of work more separately. Nowadays, though, there's a greater push towards trying to get software engineers into these like DevOps roles, they're called, which is development operations, which is essentially a blending of people who are comfortable programming and people who are comfortable deploying And that's something I guess we want to keep you in your mind throughout the course, is that we want you to feel like you're not just a programmer, but someone that can understand the life cycle of, okay, well, we have to write our code and test our code and release our code and then keep going back through it. The main reason I think this has happened, this like merging, is because I think tools have gotten a lot better. Like nowadays, programming languages are a lot easier than they were 20 years ago. Deploying stuff was a lot easier than it was 20 years ago. Like even 10, 15 years ago, if you worked at Telstra, or like Telstra, some other company, they'd have like a giant series of rooms, like server rooms with just endless servers, and there'd be all these people on site that need to maintain them and all of this stuff. Whereas now most stuff these days is kind of done up in the cloud. So everything's getting a lot easier in the software world. That's for sure. So yeah, any last questions about this? Sorry for the delay again. It just takes a moment. What happened? Oop. What happened? Oop. No questions. So great. All right. We're gonna have we're gonna have a 5-minute break. So just before we have that 5-minute break, I'm trying to do something different this term, and I'd really love your assistance with it. So if you could all please, we're going to do this after every little lecture we have. If you could just click on this link that I posted in the chat. Don't worry for the people who are watching this recorded. It doesn't really matter. We just did a little lecture on the software development lifecycle. If you could just, I think this works. If you could just like vote on this thing, that would be really good. I just want to start like collecting some data this term about different lectures, so I can like figure out where we need to like invest more time, basically. But here is the polls just for people curious. I don't know. I was like going through the lectures yesterday, and I was like, man, I feel like most of these are fine, and some of them are. It's full. All right. Well, there you go. How many people filled it out? 25 or something? Sorry about that. Okay. Sorry, that's okay. I'll find something better than that. So we're going to take a 5-minute break. We'll start up at 1:15, and then we will get stuck into Git, which is the last thing today. And then yeah, that's it. And then we move on to tomorrow. So 8 minutes, then we'll keep going. I'll put on the soothing music.